Today, we're diving deep into the hidden architecture of numbers. They might seem kind of random at first glance, but there's this really elegant structure connecting them all. It's a system we're going to map out together.
Have you ever really stopped to think about it? It's not just some chaotic mess of digits. There's a hidden logic to it, almost like a family tree that connects every single number out there. So let's start by taking a look at the big picture. All right, so first things first. Every good map needs a key, right? We're going to start by looking at the whole landscape of numbers and see how they're all sorted into a few main families. What I really love about this chart is just how simple it makes everything. Now, you'll notice the text is in Malay, but don't worry, the concept here is totally universal. So at the very top level, numbers fall into three big families. You've got integers right there, then pecahan, which just means fractions, and perpuluhan, which are decimals. Let's get to know each one a little better. Okay, so let's break that chart down and actually look at each of those families one by one. First up, we've got the integers. These are your classic, solid, whole numbers. We're talking no fractions, no decimals, none of that fancy stuff. They can be positive, like 1, 2, 3, or they can be negative, like -1, -2, and so on. And of course, smack dab in the middle, you've got 0.
Next, we have fractions, which you can see on the slide as pekach. Pretty straightforward. These numbers just represent a part of a whole. So whether it's something simple like 1/2, or a little more complex like -9/2, they let us get super precise when a whole number just won't cut it.
And our third family is decimals, or perpuluhan in Malay. Honestly, they're really just another way to write those in-between values. From a precise measurement like 3.24 to a tiny negative number like -0.1, decimals are absolutely everywhere.
Okay, so we've got our three families. We know who's who in the number world. But, the real magic starts when we look at how they all relate to one another. Like, how are they built and how can we break them down?
And that brings us to two huge ideas: breaking numbers down and building them up. We break them down into their basic ingredients, which we call factors, and we build them up by multiplying, creating what we call multiples. So think of it like taking apart a Lego set versus building a new one.
Let's start with taking things apart. We're about to dive into the world of factors. These are the hidden building blocks you'll find inside every single number.
This chart maps out the process perfectly. Again, don't worry about the Malay text. Just focus on that left-hand column under the numbers 12 and 18. Our goal here is to find something called the greatest common factor, or GCF. In simple terms, we're looking for the biggest number that divides evenly into both 12 and 18.
The logic behind this is so simple and elegant, you're going to love it. First, you just list out all the factors for each number. So for 12, that's 1, 2, 3, 4, 6, and 12. For 18, it's 1, 2, 3, 6, 9, and 18. Step 2, you find all the factors they have in common. In this case, that's 1, 2, 3, and 6. And finally, you just pick the biggest one from that list.
It's 6. The greatest common factor of 12 and 18 is 6. It's the largest building block that they share. Simple, right?
All right, now let's totally flip the script. If factors were all about breaking numbers down, multiples are all about building them up, bigger and bigger.
So we're back to our trusty chart, but this time I want you to look at the right side. We're going to use a couple new numbers for this one, 6 and 8. Here, we're building up to find their lowest common multiple, or LCM. The goal is to find the very first, smallest number that's a multiple of both 6 and 8.
The process here totally mirrors what we just did for factors. First, you list out the first few multiples for each number. For 6, that's 6, 12, 18, 24, and so on. For 8, you've got 8, 16, 24, 32. You get the picture. The second step is to find the very first number that shows up on both of those lists.
And there it is, 24. That's our lowest common multiple. It's the very first destination that both numbers arrive at as they travel up the number line. So, we can break numbers down, we can build them up. It's a pretty neat mathematical trick. But what's the point? Why should you actually care about GCF and LCM in the real world?
Well, this is where it gets really practical. Let's think about the GCF. Let's say you have 12 sandwiches and 18 cookies for a big picnic. The GCF tells you the biggest number of identical snack packs you can make with nothing left over. And LCM,
That's the absolute key to scheduling. It helps you figure out exactly when two buses on different routes will show up at the same stop at the exact same time. It's the hidden math that makes planning and logistics actually work.
You know, it all points to a deeper truth. Understanding stuff like factors and multiples isn't just about getting through your homework. It's about learning the fundamental language that describes all the patterns in the world, which is why I absolutely love this quote.
So the next time you're trying to sync up your schedule with a friend, or maybe split some snacks evenly with a group, just remember this elegant power of breaking down and building up. What part of your world is just a GCF or an LCM problem waiting to be solved?